Hello everyone, myself Kaushik, currently pursuing my studies in Sri Venkateswara College of Engineering. Hello everyone, welcome back to my channel. Today we are diving into two crucial aspects of urban planning: landfill site selection and urban flood management. Now let's look into the introduction part. Landfills are essential for waste disposal, but their location significantly impacts our environment and communities. Safe disposal of waste requires careful landfill selection. Proper siting minimizes environmental impact and protects public health. Delving into these criteria, this presentation will explore how we can achieve a sustainable balance for waste management. Criteria for selection of landfill. Environmental consideration. Environmental consideration includes geology, hydrology, and topography. Geology. Underlying rock formations should be stable and impermeable to prevent leachate contamination of groundwater. Hydrology. The site should be located away from water sources like aquifers, rivers, and wetlands to avoid surface and groundwater pollution. Topography. Clayey soils with a genuine slope and ideal for landfill liners while steeper slopes can increase erosion risks. Locational criteria. Lake or pond, river, flood, highway, habitation, public parks are the locational criteria. Lake or pond. No landfill shall normally be constructed within 20 meters of any lake or pond. Because of concerns regarding runoff of water contaminated, a surface water monitoring network with approval of SPCB or PCC shall be established. River. No landfill shall be constructed within a 100-meter mark of navigable river or stream. Floodplain. No landfill shall be constructed within a 100-year flood plan. A landfill may be built within the floodplains or secondary streams if an embankment is built along the stream side to avoid flooding of the area. However, landfills must not be built within the flooded plains of major rivers unless properly designed protection embankments are constructed around the landfills. Highway. No landfills shall be constructed within 500-meter mark of the right way of an state or national highway. Habitation. A landfill site shall be at least 500 meters from the notified habitated area. A zone of 500 meters around a landfill boundary shall be declared as a no development buffer zone after the landfill location is finalized. Public parks. No landfill will be constructed within 500 meters of public parks. Site selection. Hazardous waste landfills should preferably be located in areas of low population density, low alternative land use value, low groundwater contamination potential, and at sites having high clay content in the subsoil. A hazardous waste landfill will be selected following the guidelines published by MOEF. The step by procedure will be as follows. Embanking search area taking into account the location of the waste generation units and a search radius, typically 5 to 50 kilometers. The search area will be so chosen that it minimizes the number of hazardous waste landfills in any region or state. Identification of a list of potential sites on the basis of availability of the land, collection of primary data, restrictions listed in the locational criteria. Collection of primary data as follows. Topological maps. A topographic map will help finding sites that are not on natural surface water drains or floodplains. Topographical maps may be pronounced procedures from Survey of India. Soil maps. These maps, primarily made for agriculture use, will show the types of soil near the surface. They are limited use as they do not show types of soil a few meters below the surface. They may be procured from Indian Agricultural Research Institute. Landfill selections. How do we select the landfill selections? Landfills may have different types of selections depending on the topography of the area. The landfills may take the following forms. The first one is above ground landfills. Second one is below ground landfill. Third one is slope landfills. And the fourth one is valley landfills, and they are also called as canyon landfills. Now let's look into the measures of urban flood management. To create sponge city is one that can hold clean and rainwater in a natural way using an ecological approach. Green rooftop garden green garden roofs absorbs rainwater and help to mitigate flooding. It reduces stormwater runoff and for the environment. It prevents combined sewer water overflow. Separating rainwater from the sewer system in order to improve water management and protect the sewer system from damage, the separation enables the wastewater treatment plant to function properly without it being overburdened by large quantities of stormwater. Sustainable drainage, permeable pavement, sidewalks, and gardens. Preparedness before the flood impact, such as flood forecasting and warning. Readiness upon flood arrival. Emergency responses during the flood impact. Recovery and rehabilitation after the flood impact. Multidisciplinary agencies like government, non-government, NGOs, etc. All these departments are integrated and are involved to manage the floods. Construction of flood protection areas. These are the urban flood management measures taken. Now let's look at the conclusion part. Delineating the urban flood vulnerability zone aids in quick decision making for sustainable urban flood management. Each thematic map were designed with proper weightage through AHP technique and then integrated by weightage overlay analysis tool in GIS to prepare the UFVZ map of study area. The map showed 42% of study area is prone to moderate flood vulnerability. The results indicate that in urban environment study area, the flood disaster is more influenced by anthropogenic impacts. The present work shows a simple and cost-effective empirical method for delineating flood vulnerability zones using remote sensing and GIS from the available data. Preparedness before flood impact, such as flood forecasting and warning.